Unexpectedly, cosmic events of extraordinary scale occur billions of kilometers from Earth, resonating across the universe. An equivalent event is approaching, causing astonishment even among specialists. A red giant star located at the outer edges of our system is transmitting strong signals across the universe, captured by the James Webb Space Telescope. Cosmologists have unveiled deeply concerning revelations about this magnificent celestial body. Renowned astrophysicist Brian Cox issues a dire warning. A pressing question emerges. Are we on the verge of witnessing a catastrophic cosmic explosion that could permanently alter the familiar night sky? Before delving further, make sure to subscribe to our channel if you haven't already. Now, the burning question remains. Will this impact Earth, and will it be observable from our planet? Stay tuned as we explore the answers to these compelling questions in this video. In the vastness of the universe, where the cycle of grand birth, life, and death unfolds in mesmerizing splendor, one particular star has recently captured the attention and concern of both astronomers and the public. This star, known as Betelgeuse, stands out prominently as a red supergiant in the Orion constellation, showcasing immense size and age. While its striking reddish hue and fluctuating brightness have long fascinated observers, recent events have heightened interest in this magnificent behemoth. As we delve into the essence of Betelgeuse, we find ourselves approaching the very brink of a potentially staggering event in the star's life cycle. But what do these changes in Betelgeuse's behavior signify? Could we be witnessing the onset of a grand cosmic spectacle of unimaginable scale? Betelgeuse, boasting a size over 700 times greater than our Sun, remains a colossal giant among stars. Its sheer magnitude defies human imagination. Imagine a star so vast that if it replaced the Sun, its surface would extend beyond Mars' orbit, enveloping Mercury, Venus, Earth, and Mars within its expansive grasp. This extraordinary size not only underscores Betelgeuse's immense stature, but also marks its stage in the stellar life cycle. As a red supergiant, Betelgeuse is in the twilight phase of its existence, characterized by expansion and cooling after a lifetime of fusing hydrogen into helium at its core. Questions arise about Betelgeuse's age. While relatively young in human terms, estimated at around 8.5 to 8.8 million years old, it is ancient in the context of stellar lifespans. Its current status as a red supergiant reflects the culmination of millions of years of stellar evolution, marked by profound transformations from a hot blue star to the enormous red giant we observe today. The journey of stars like Betelgeuse unfolds as a narrative of continual change, driven by the relentless forces of nuclear fusion and gravity. One striking feature of Betelgeuse's current phase is its vivid red hue. This deep red color results from its relatively cooler surface temperature compared to stars like our Sun. While the Sun shines at about 5,500 Kelvin, Betelgeuse's surface is cooler, around 3,500 Kelvin. This cooler temperature allows Betelgeuse to emit light in shades of red. However, this hue is not merely an aesthetic trait. It provides insights into the star's physical state and ongoing processes within its vast gaseous domain. Adding to the intrigue surrounding Betelgeuse is its peculiar color history. Ancient texts from Roman and Chinese sources suggest that nearly 2 millennia ago, Betelgeuse appeared yellow. It wasn't until the 9th century that Arabic astronomers described it as red. This historical change in color is not just a footnote in astronomical records, but serves as an indicator of the star's transformative journey. The fluctuating brightness of Betelgeuse adds another layer of fascination. As a semi-regular variable star, its luminosity undergoes periodic variations. This rhythmic dance of brightness has captivated astronomers and stargazers for centuries. Typically, Betelgeuse follows a 400-day cycle, alongside a longer 5-year cycle, noted as early as 1836 by Sir John Herschel, and possibly even earlier in indigenous oral traditions. What truly sets Betelgeuse apart, however, is its unpredictability. Unlike many stars that follow predictable patterns, Betelgeuse occasionally deviates from its usual dimming and brightening rhythm. This anomaly points to complex and less understood processes occurring within its massive structure. Recent significant discoveries have captivated astronomers worldwide. In late 2019, Betelgeuse experienced an unexpected and dramatic event, now famously known as the Great Dimming. At that time, the red supergiant began to undergo a mysterious dimming, losing brightness at an unprecedented rate. This phenomenon, carefully studied by Andrea Dupree, the assistant director of the Center for Astrophysics at Harvard and Smithsonian, and her team using the Hubble Space Telescope, revealed that massive material ejected from Betelgeuse formed a dust cloud that obscured the star's light. This event underscores the ongoing complexities of Betelgeuse's life cycle and its potential to surprise and astonish us as humanity continues to observe this cosmic giant. One question remains: what lies ahead for Betelgeuse, and how will its fate shape our understanding of the universe? Betelgeuse's story doesn't end with the Great Dimming. Scientists worldwide are meticulously monitoring its behavior to understand what it might signal about the star's future. Some experts suggest that Betelgeuse could be nearing the end of its life cycle, potentially culminating in a supernova, a rare and spectacular event. A supernova occurs when a massive star exhausts its nuclear fuel, causing a gravitational collapse followed by a powerful explosion. If Betelgeuse were to explode, it would become as bright as, or even brighter than a full moon, visible in the daytime for weeks. This would be a once-in-a-lifetime event for observers on Earth. However, it's important to note that predictions about Betelgeuse's supernova are highly uncertain. While the star is in the final stages of its life, it could take thousands or even tens of thousands of years before the dramatic finale unfolds. Astronomers are cautious not to overinterpret the current observations, as many red supergiants exhibit variability without an imminent explosion. The observations of Betelgeuse also highlight the time delay problem inherent in astronomical studies. Since Betelgeuse is approximately 725 light-years away, any changes we observe today actually occurred centuries ago. This temporal gap complicates real-time predictions and reminds us of the immense scales of time and space involved in cosmic events. The scientific significance of Betelgeuse's behavior provides invaluable opportunities for astronomers to study the late stages of stellar evolution. The data collected during events like the Great Dimming allow scientists to refine their models of how stars evolve, eject material, and eventually end their lives. For example, studies using the Hubble Space Telescope and other instruments have shown that Betelgeuse's outer layers are turbulent, with massive convection cells churning material to the surface. These processes contribute to the ejection of gas and dust, forming a shell around the star that can obscure its light. The insights gained from Betelgeuse are not just relevant for understanding this particular star. They also help us comprehend the broader life cycles of stars and the formation of heavy elements in the universe. When a massive star like Betelgeuse explodes, it enriches its surroundings with elements such as carbon, oxygen, and iron, the building blocks of planets and life itself. Implications for Earth. While a Betelgeuse supernova would be a breathtaking spectacle, scientists assure us that it poses no direct threat to Earth. The star is far enough away that any radiation from the explosion would dissipate before reaching our planet. However, the event would undoubtedly have a profound impact on our understanding of the universe. It would provide a unique opportunity to study the mechanics of supernovae in real time, offering unprecedented insights into these cosmic phenomena. Looking ahead, as astronomers continue to monitor Betelgeuse, the star remains a fascinating reminder of the dynamic and ever-changing nature of the cosmos. Whether its supernova occurs tomorrow or thousands of years from now, Betelgeuse's story underscores the intricate processes that govern the universe and our place within it. In the meantime, Betelgeuse continues to inspire awe and curiosity, inviting us to look up at the night sky and marvel at the wonders of the universe. It serves as a reminder that even the most massive stars, seemingly eternal, have lifespans and stories that are part of a greater cosmic narrative. Stay tuned as new discoveries unfold about Betelgeuse and other celestial phenomena, pushing the boundaries of our knowledge and deepening our connection to the vast universe we call home. The 3-month occasion, generally marked by twice the typical measure of material shed from Betelgeuse's southern hemisphere, was notably significant, especially considering that all stars, including Betelgeuse, persistently shed mass but at a much higher rate than our Sun. The size of this mass discharge and the subsequent darkening sparked conversations among stargazers regarding whether this event could signal a looming supernova explosion. The proximity of Betelgeuse, located approximately 725 light-years from Earth, adds to the intrigue. If such a blast were to occur, it would be visible from Earth, presenting a fascinating opportunity to closely observe a supernova. Yet, the question remains, what does this darkening event mean for Betelgeuse's future? Does it signal an impending supernova, or is it merely a transitory stage in the star's vast and complex journey? Various hypotheses have been proposed to shed light on this phenomenon. One theory suggests it could be a phase in the supernova process, gaining traction due to the widespread belief that Betelgeuse is nearing the end of its life cycle. Another widely accepted hypothesis involves dust potentially originating from the star itself, blocking our view of Betelgeuse. A third explanation examines changes in the star's photosphere, its apparent surface layer, which could affect its visible brightness. Extensive investigations using various observational methods contributed to unraveling this mystery. Spectroscopic evaluations revealed the decline in Betelgeuse's effective temperature, suggesting the likelihood of a significant dark spot on the star's surface. This hypothesis was supported by observations indicating a temperature drop of at least 170 Kelvin during the dimming period, highlighting significant surface changes. Ultimately, the key to understanding this extraordinary phenomenon came from humanity's careful gaze into space. The Hubble Space Telescope provided precise observations, revealing that Betelgeuse's dimming was likely caused by a substantial ejection of heated material into space. This material coalesced to form a dust cloud, obscuring part of the star's surface and reducing the amount of light reaching us from Betelgeuse. The formation of the dust cloud was attributed to superheated plasma, which erupted from a massive convection cell on the star's surface and traveled through its scorched atmosphere to cooler outer layers. Upon cooling, this plasma formed dust particles, resulting in a cloud that blocked light from about a quarter of the star's surface. Hubble's ultraviolet light spectroscopic observations, which began in January 2019, played an essential role in reconstructing the timeline leading up to Betelgeuse's dimming. These observations detected signs of dense, heated material traveling through the star's atmosphere in the months preceding the darkening event. By December 2019, other ground-based telescopes also observed the star's decreasing brightness, particularly in its southern hemisphere. Initially, this material appeared brighter than the star's usual radiance, eventually culminating in the formation of a shadow as it dissipated outward and cooled. The concept was straightforward. This outward flow of material and the resulting shadow were responsible for the star's sudden dimming. The size of this ejection is genuinely astonishing, thrusting Betelgeuse into the cosmic spotlight. The star expelled an estimated 400 billion times the mass typically released in a standard coronal mass ejection. This expelled material was thought to be sufficient to outweigh our Moon several times over, marking a significant event not just for Betelgeuse but also for advancing our understanding of stellar mechanics. What are the implications of such a massive material release for Betelgeuse and broader theories of supernovae? Traditional wisdom suggests that red supergiants like Betelgeuse routinely shed mass before reaching the catastrophic peak of their existence. However, the scale of this discharge challenges this notion, hinting at a potentially more volatile and unpredictable final stage for these stars. Could Betelgeuse be gearing up for its grand finale, a supernova explosion, within the next few centuries? Later research speculated on the timing of such an event, suggesting it might occur sooner than previously anticipated, perhaps in just a few decades. The concept of the bow shock adds another critical layer to the Betelgeuse puzzle. As this massive star races through space at about 67,000 miles per hour relative to its surrounding interstellar medium, it creates a bow shock, similar to the wake formed by a moving boat's bow. This phenomenon arises from the star's outer layers interacting with interstellar gases and dust, offering a spectacular display of the star's dynamic behavior and its connection to the cosmic milieu. But what about Betelgeuse's recent behavior? Its surface cooling and decreased density observed following the ejection event, leave the star in a disturbed state, even years later. Hydrodynamic simulations suggest a link between the star's convective activities, the mass ejection, and the subsequent changes in its oscillation modes. This ongoing instability raises questions about the internal processes driving these changes and their potential implications for the star's future. Furthermore, the observed mass loss rate of Betelgeuse exceeds that of many other stars, reflecting a complex interplay of internal forces with energy continuously dissipating through shock heating and mass ejection. Betelgeuse's rhythm is shifting. The very nature of these mass losses points to the star's dynamic and somewhat erratic life cycle, prompting astronomers to rethink their models of stellar evolution.